Okay, now I want to go back and investigate again the addition of complex numbers. And there are still some insights to be gained in this process. So let me remind you how we can represent a complex number on a two-dimensional graph. And that if we have a complex number here, we represent our complex number, let's say, is the number x plus iy. So we write x plus iy. And we use a orthogonal coordinate system. This is called a Cartesian coordinate system, where we have two perpendicular axes. Here we're going to let the horizontal axis represent the real part of the complex number, the vertical axis, the imaginary part. It's called Cartesian because it's named after Rene Descartes, the French philosopher and mathematician, who may have been the first person to use this kind of notation. Actually, I sort of doubt it, but it's called Cartesian after Descartes. So here we have we represent the x value on the horizontal axis, and then we represent the y value on the vertical axis, and we plot this point right here. And this point is the representation of the point x plus iy. Now notice we're going to come back in a minute, or maybe more than a minute, and we're going to talk about representing it in terms of the length of this line and this angle here, but we'll be back on that. Now let's look at a specific example, and because I want to show the implication of this kind of representation for a complex number. I'm going to look at the example where I have the complex number 3 plus 2i, and I'm going to add it to the complex number 2 plus 2i. So representing this complex number on our Cartesian axis, we go out here on the horizontal axis to the number 3, and then we go up on the vertical axis to the number 2 or 2i, and then this represents our point 3 plus 2i. So here we have the blue line also representing that number, the blue line going from the origin out to the number itself. And we can do the same thing with the number 2 plus 2i. We go out on the horizontal axis 2, and we go up on the vertical axis 2 to represent the 2i. So this is our number 2 plus 2i. Now if you remember adding complex numbers, what we do is we add the real parts, and then we add the imaginary part. So we add 2 plus 3, and then we add 2i plus 2i to give us our addition, our addition of two complex numbers. So I'm going to represent that addition on this graph right in here. So I've already plotted out the number 3 on the real axis, and then I go up 2i. So this is the number 3 plus 2i right here. So this is 3 plus 2i right there. Okay, now I'm going to add this number to it, and this is the number 2, okay, 2 plus 2i. So I go out an additional 2 on the real axis, so this will be the real value of the added number, and then I go up an additional 2, so I go up to 3i, and then I go up the additional 2i to represent the added imaginary part of the complex number. So I'm going out to 3 plus 2. Let me draw that number right in here. So I'm going out here. I don't want to use that. I want to use a straight line. Okay, so I go out here to this point, and then I go up here and go up an additional 2, which is what I get when I add the 2i of the second complex number to the 2i of the first complex number. So I plot this here, and this point right in here represents our new complex number, which is the sum of the two right in here. So this is the sum of the two numbers. So notice that what we have here is that this new number is in fact just what we get when we sum our first blue line, and then we add on to it, tack on to the end, the second blue line. Okay, so this line with the direction and size plus this line with its direction and size gives us our new complex number, which now has the coordinates of 3 plus 2 This is 3 plus 2 is the real part of the new number, and the imaginary part is 2i plus 2i, or plus 4i. So that's pretty interesting how we can represent it graphically. Let me show you perhaps a little bit more of an extreme example. So let me erase this. Now let's suppose we have these two complex numbers here. We draw an axis. So we have this complex number here. I'll represent by this blue line, giving us the real and imaginary parts. And then we're going to add to it another complex number. Let's say that's represented by this line. If we were to add, and this number could be, this could be perhaps a 5 plus 2i. And this one might be a negative 2 plus 5i. Negative 2 plus 5i. Now I add these two numbers together on the same graph, and it might look something like this. Where I have the first complex number comes out like this, about that. The second one comes out like this. So this new line, this sum of this line plus this line, is represented by this complex number. So you see that if we just take this line here and we add to it, that we take this line and we add to it this line, keeping the direction and length the same, we will in fact get the value of the new complex number. So you begin to see how we can use geometry to some extent to represent our complex numbers. Okay, so let's try, I'll give you some examples here to work through of how you can represent this addition using this form. This is called a vector representation for adding complex numbers.